Hi everyone, we are live and we're on the 5th session. So on the 5th session, it seems like I went and picked up a little cool sometime earlier this week, and it kind of not bad, coming and going. So I kind of fighting it off, but I just want to kill off my voice so I can be my usual shouting self. So I hope everybody's hearing me clear. First things first, find the like button, introduce yourself to the like button. Press like. We're getting ready to go. Some of you all already put in the answers to this, right? I hope everyone is revising. So don't only have your only revision in these Sunday sessions. You should be doing revision by yourself. I took a survey, when was it? I think it was in the first session, and I asked how much papers everybody do per day or per weekend. Some of you all have really high numbers, and some of you all have 0. So you need to increase that number. We are in the month of February, and February is the shortest month in the year. Shout out to anybody born in February. And after February comes none other than March. And at the ending of March is fun and games. Exam. At the ending of March is exam. So we're right there, right around the corner. We are getting very excited about this. Let's go. What's the answer here? So with these kind of questions, what I want to do is write it out. So there's 300s of thousands, 1 tens of thousands, 3,000, 0 hundreds, 2 tens, 2 ones. And if I write it going down like this, there'll be 3 1 3 0 2 2, which is what Amanda has. Is it Amelia and Amanda? So big up on yourself. What is 39 over 4 as a mixed number? 39 over 4 as a mixed number. So we want to divide the numerator by the denominator. And we want to see how many times 4 can go into 39. How many times can 4 go into 39, class? Well, 4 by 10 is 40. So 4 nines, 9 times. But 4 nines is 36. And that's a remainder of 3 to reach the 39. So the answer is 4 can go into 39 9 times, and 3 is the remainder. It goes over the divisor, which is 4. So 9 3/4, which is what Kyle has. Big up yourself, Kyle. Although that slash went the wrong way by Kyle, we're going on with that slash. 5 squared minus the square root of 49. 5 squared is 25. And the square root of 49 is 7, because we practice our square numbers this week and we know real plenty. So 25 minus 7 is none other than 18. This is easy things we're doing here. And Jordan also found it easy. Big up yourself, Jordan. Lots of people getting the correct answer. I just picking 1 or 2 every now and then. All right, so 4 subtract 4.91 from 6.42. 6.42 minus 4.91. I'm seeing some interesting stuff may occur here. 1 from 2 is 1. 9 we can't get 9 out of 4. So what we're gonna do is look over here and hijack one of these numbers. So this will drop to 5, and I'll bring him across here, and he'll become 10 of this. So it's 14. 10 plus 4 is 14. 14 minus 9 is now 5. And 5 take away 1 is now 1. So the answer is 1.51, which is what my friend here has. Angelo, big up yourself. A large box containing 259 crayons were divided into 7 sections. How many crayons were in each section? This is just a simple division. How many times can 7 go into 259? 7 can go into 2 0 times, but 7 can go into 25 3 times. 3 7s are 21. So we know from 21 to 25, there's a remainder of 4. So let's put that 4 there. And 7 can go into 49 7 times. So the answer is 37 crayons in each box, which is what Caleb has. Big up yourself, Caleb. Marcus bought these 3 items. What is the total cost of the item? So what's the total cost of all the items? That means we need to do a nice sum, an addition. So let's put 31.50. Let's put 8.20, and let's put 14.50, and let's add them up. Well, I know 50 and 50 make 1, so this will just carry it over to like 12, 1.2. So I'll bring the 1 here, right? That's good so far. So 2 plus 8 is 10, and a 4 is 14. So I'll bring the 4 here and I'll bring the 1 there. Then this 1 and 3 is 4 plus 1 is 5. So $54.20 is excellent, which is what Antoinette and Darshan Ramroop has, which is totally the correct answer, 54.20. Shade the fraction of the second shape to complete the statement below. So we are doing fraction addition here. This is a quarter. And in the final part of this, I want 3 quarters. So I want to add on 2 more quarters. So I want to add on 2 quarters. Does that make sense? The S family. Why is the S family saying sis? What's up, the S family? A few people are trying to stop me. Was there something that I missed? Excuse me. I hope I didn't type anything wrong. So how much should I shade? Well, I should shade. You can actually see what's missing here, you know, to make up here. You see it? So in terms of that, I would want to shade this. Now they just suggested that I shade. So nothing too big going on here. Let me shade it in orange. Of course, you'll be shading it in your pencil, gray. Nothing too big going on there. So I'll shade a half, or as this is divided into 16ths, this is 8. This is 8 out of the 16 blocks I will have to shade here, which is what I see people typing. Insert the missing numbers in the boxes below. I feel like we didn't do one of these questions since we started, and these questions are pretty popular. So let's see if we can do this. And it's an addition. Always look to see what the operation is. So it's an addition. So 1 plus something gives us 7. So let's put 6 here for now. 1 plus 6 equals 7. And if I put 4 here, does this work out? 4 plus 2 is 6. 7 plus 3 is 10. So this works out really well. This works out really, really well. Sometimes there are more tricks in these questions, eh, boy? Sometimes there are more tricks in these questions, because sometimes you may need to put something here to bring across a 1. So you may see one of that appear in later exercises. 2,640 meters means we need to bring the point back 3 places if we want to convert it to kilometers. And we will get 2.640 kilometers, which is what Kanisha has. Well done, Kanisha. 2.64, right? What is the time? What is the time shown in the clock below? Watch the hour hand first. Folks, ladies and gentlemen, boys and girls of all ages, always take a look at where the hour hand is doing first, what the hour hand is doing first, and the hour hand has just passed 12. It hasn't reached 1 yet, it's past 12, so I know it's 12 something. Now, what do I do to figure out what 12 something is? 5, 10, 15, 12, 15 is the answer, which is what Kavir has, although he forgot to put, he forgot to type in Kavir colon, bro. That's that, yeah, you must put that, right? Chase bought 3 mystery items at the store. Ooh. And the mass of each item is shown below. Calculate total mass. So here we are doing some addition yet again. So we have 3.5, which is the same as 3.5. We have 2 and we have 4. Easy stuff, man. Easy stuff. Easy stuff. Suan, why you keep writing so people with the you may get timed out if you keep spamming right? Have a good reason for spamming like if you need me to check over something, because I would always watch that. As a teacher, you are very allergic to and miss. Anytime I hear I immediately have to tune. Anytime a teacher say anytime somebody say miss, you have to watch. So if you spam that, you could end up outside, bro. 15. So calculate the total mass of the 3 items. We're doing a nice little addition here. You all working at me? Keeping up to the pace? Are they keeping up? 3.5, 2 kilograms, 4 kilograms. So 5 plus 0 is 5. 3 and 2 is 5 plus 4 is 9. It's a third, not a half. Where did I put a half? What are y'all talking about? One third. One third. I am lost. Where did I put that? Shade the fraction of the shape. This is a half. 2.6, 10. Oh, 3.3. Oh, this one. Oh yeah, I wasn't in here. So 3 or 1/3. And I put a half. Okay, my bad. Okay, well, that gets a little problematic to do in decimals because 1/3 as a decimal is 3.33333. So I really don't want to deal with that in decimal. So I just add the whole and I'll add the fractions after. That's what you're saying. C4. All right, we'll do it. So the whole would be 3, 2, 4. 3 plus 2 plus 4, which will be 9 kg, and the fraction was 1/3, which there were no other fractions to meet the 1/3. So the 1/3 is all alone by himself. So in the end, it's just the whole plus the, so it's what calculate the total mass of everything. That was the question, calculate the total mass. So 9 and 1/3 of a kilogram. There wasn't any. I would advise to leave it in this format. There wasn't any instruction to have it in any other format. Write down the length of this object. So what does this object look like? This object looks like, I don't know what this object looks like. Write down the length of this object. It's ended on 23.5, but it started on 18.2. So what's the length of this object? The length is 23.5 minus 18.2, which is 5 from 2 is 3. Bring across this. 13 minus 8 is 5. This is 1. So it's 5.3 centimeters. Is that what we are getting? Kieran is also saying 5.3 centimeters, which sounds really good to me. Suan is saying that as well. From the list below, circle the most appropriate metric unit for measuring the mass. The mass, right? The mass. So we want to measure how heavy it is. So the mass of the watermelon. So liters is volume, grams is mass, millimeter is length, and kilogram is mass. So which one is better between grams and kilograms for the watermelon, boy? Grams is normally for smaller. Grams is normally for smaller quantities, smaller weight, smaller masses. So we'd go to kilograms. How many kilograms do you weigh? I would guess that most of you all are what? How many kilograms? 3 objects. How many watermelons are you? 3 objects are placed on the scale as shown below. The scale is now balanced. What is the mass of the circular object? Well, if this is 4 kg and this is 1.350 kg and we're missing something, it means whatever is missing to make up the 4 kg is inside there. So to find the missing number, I would need to subtract. So I can subtract, and since my answer is in grams, I will work in grams. 4,000 minus 1,350. Let's do some bringing across, boy. No, he gets this thing. He gets this thing. So when we subtract, what do we get? 0 from 0 is 0. 5 from 10 is 5. 3 from 9 is 6. And 1 from 3 is 2. Is that correct? Is it 2650 grams? And we want to pay special attention to the units. If they put kg here, we'd have put 2.6, but grams. So we get there. Definitely not going to use division for this Amelia Amanda. Write down the name of a solid that has a uniform cross section. I could go with cuboid. Can you give me some? So cuboid has a uniform cross section. I can also use cylinder. I see Kamani saying cylinder. Yeah. I can even use a cube. Yes, a cube is also correct. Cube, square sides. I can use a triangular prism. Yep. What I cannot use is pyramids. What I cannot use is pyramids or cones or stuff like that, right? So any one of these here could work. Which angle in the shape below is more than a right angle? This is less. This is equal. This is a right angle. This is another one here. This guy over here, he looks like he is doing a little moreness. So to describe that angle, you can just write the letter D for SCA. More precise would be ADC, which still denotes two angles, but B would work. Which of the shapes shown below is not symmetrical? I find I find this shape looking guilty. This shape, all of the other shapes looking confident. All of the other shapes looking, confident in their self that they know they're symmetrical. This shape just looking guilty, boy. What do you think? This shape just looking guilty. This shape is guilty. B is definitely not symmetrical. You can see it. You can see him just looking. All right. This has lots of lines of symmetry actually. Yeah? That's why he's so confident. This one has two lines of symmetry, and this one just has one line of symmetry here. You can't squeeze out any line of symmetry in this unless you probably do a curve of symmetry. B is guilty, man. The water drop. The table below shows the number of books sold in 3 weeks. Calculate the mean number of books sold on a weekly basis. So some of these questions are pretty straightforward, man. Some of these questions are straightforward because mean is our sum divided by the frequency or the number of items or the number of goals or the number of whatever data sets. So let's add it up. 43 plus 36 plus 38. How many of you are super quick in addition? 8 and 6 is 14 and 3 is 17. So I'm putting my 7 here and my 1 there. So I end up with 4 and 4 is 8 plus 3. So isn't that like 117? Kind of scary number, but is 117 a prime number? Let's just double check. 3 plus 6 is 9. Okay, maybe it's not. Maybe it's a number that has just a few factors. 5, maybe like 13 or something. 8. Okay. And then we need to divide by 3. So 117 is divisible by 3. Let's see how many times. Because it's 3 items, right? 3 weeks. I hope my voice can last for the whole session. 3 into 11 is 3. Mean that 2. 3 into 27 is 9. Nine books sold. 9 books. 20. The incomplete bar graph below shows the number of students and the hobbies they enjoyed. A total of 120 students indicated their favorite hobby. Oh, dance is missing. Dance is missing. See if I could figure out how much going in dance day. How much you put in dance? I have this thing that is numb my throat. Let me go and see if I can. Let's figure out what's going on in dance day. Coming back now. Let's see my green screen moving. Oh, good. Let's say not vibrating. That's my phone ringing and thing. My phone vibrating. That's not right. My phone vibrating, but like I can't find it. All right. Did I skip a question? Number 19. Oh. The missing question. The case of the missing question. Y'all, I'll go and find that question just now. Number 18, trying to escape we, but I'll find that question later. Let me keep going. How we can do number 18 that? The incomplete bar graph shown below shows the number of students and the hobbies they enjoyed. A total of 120 students. How much are they get? They get, I seen 18, I seen 20. I seen 18, I seen 20. Where is this? Where is this boy? So we have 20 here. We have 40 here. This is the last question in section 1. And it's supposed to add up to be how much earlier? It's supposed to add up to be 120. How much we have so far? 40 and 30 is 70, and 10 is 80, and 20. We have 100 so far, 100 so far. So how much I should put in this column? They say to draw it. So you need to come now and draw. Hey, no, that's too high, that's too high. You need to draw 20. 20 is missing. Draw 20, that's what you're saying? Best. So we miss out a whole number. We miss out a number 18. And by we, I mean me. So we'll come back and find that. 35, we're coming back for number 18. I'll remind me in the end, right? 35 erasers fit exactly along the length of whiteboard. Each eraser has a length of 4.2. Calculate the total length. So the total length will, of course, be, just double check a question here. Did I make a mistake? Which one is this? This is 19. Already writing 3 into 39. Oh, I'll leave 43. My bad. I'll blame it on me being sick. 39, yes, because the mean was 39. Well, I got 39 here, but somehow in my writing, I left out a whole tree. What is going on? What's happening? Yeah. All right, so there we go. 35 erasers fit exactly along the length of a whiteboard. Each eraser has a length of 4.2. So we have a whiteboard, and they decide to line up the erasers, and I know the teachers sometimes put the 2 erasers in the corner here. But we line up 35 erasers, so that means we take eraser from every class in the school, and we're going to get the total length. So we need to multiply. We need to multiply 35 by 4.2. 35 by 4.2. All right. Okay. Let's ignore the point for now. So 4 by 35 is something. Well, let's work it out the long way, because where things happening out here. 4 by 5 is 20. Put the 2 there. 4 3s are 12 plus 2 is 140. Okay, cool. And that 0 will go here to fill in that blank, right? 2 by 35 is just 70. So I could just literally write that there. So when I add this up, I'm getting 1470. And I need to bring back the point 1. So 147, is that sounding reasonable? That sounds reasonable. 147 centimeters sounds reasonable. All right. 5/9 of a certain number is 30. What is 2/3 of the same number? 5/9 of a certain number is 30. What is 2/3 of the same number? There's a 99% chance you'll get a question similar to this in the exam, where a fraction is set as something and you need to find the whole and then maybe find another fraction. So if 5/9 is set as 30, the whole, and to find the whole, you'll need to do a reciprocal, 9/5. All right, the flippy dips, yes, well done, Nell. The flips, 5 into 30 is 6, and 6 9s is 9 less than 80. 9 less than 60. 6 9s is 9 less than 60. 6 less than 60, which is 54. All right. Anytime you need to multiply a number by 9, you can multiply by 10 and subtract the number. All right, that's what I tried to say. 54. What is 2/3 of the same number? So we need to get 2/3 of the whole. Of mean multiply. So 2/3 of 54 is how much? How many times can 3 go into 54? No, 3 can most certainly go into 54. It can go in 1, remainder 2, 3 into 24, 8 times, 18 times. And 2 by 18 is 36. So 2/3 of 36 is 2/3 of 54 is 36. And Zuna, not too sure I can pronounce the name, Janaya and Hamilton has that as well. Kyle also in the 36 squad. Number 23. The number of cherries that Sasha has is a factor of 48. All right, 48 has a lot of factors, so that's not really helping me. We can't really figure out anything yet, for sure. She ate 4, and now the number of cherries is a multiple of 5. How many cherries does Sasha now have? Oh my gosh. What will we ever do? Now, I'm thinking the best approach, and it seems like some of you all don't have the answer for this already. The best approach for this question is not to look at the factors of, we want to look at the one with the least. So 48 has factors like 48, 24, 12, 4, 3, 6, 1, 2, lots and lots and lots of factors, even 8, lots of factors with 48, but is 16 a factor as well? Maybe not. So plenty factors with 48. So the best thing to do with this question, and some of you already spring the answer, she ate 4, and now the number of cherries is a multiple of 5. So I would probably check the multiples of 5 and see which one links up. So I would check, like, I would actually check 20 first, which happens to be the answer, because 20 is close to all of these. But let me say I decided to check 15. 15 plus 4 is 19. That's not a factor. You understand? I'll check 10. 10 plus 4 is 14. That's not a factor. 14, 4, when does 4 become 8? 7, 14 times 7 is not. No. So then I check maybe 20. 20 plus 4 is a factor, 24. Why am I adding on 4? Because she ate 4. So if she ate 4, the number was the multiple of 5 plus 4. So 24 cherries is, wait, how many cherries does she now have? She now has 20 cherries. She had 24. She ate 4, turned to 20, which is a multiple of 5, and 24 is a factor of 48. Nice question, man. A nice question. I find this paper is a really nice paper. What do you think about this paper before? I feel like this is one of the nicest papers we do. The restaurant owner bought a barrel. The restaurant owner, okay, apparently we know about this guy already. He bought a barrel of 70 apples of different types. So here's a barrel, and in the barrel has 70 apples. Apples in the barrel, and in the barrel has 70 apples of different types. Red, green, and yellow. So it have red, green, and yellow apples in the barrel. There are 14 yellow. Oh, they actually gave us how much yellow it have. And we have an equal number of red and green. So equal. Okay. If it's blurry, you need to raise the setting on your side. So I'm Shekinah. You need to go on the gearbox icon and raise the setting. So it's a very easy question. A question where you want to remove the excess and get the equal sharing, right? Because these two are the same. So we can remove the excess yellow. So removing the yellow from the whole number, we go on and take out all the yellow from the barrel. 70 minus 14. How much will we get? Because they want to know what percentage of the apples are green. So we're removing the yellow. We don't care about no yellow here, boy. So 6, 1, and just subtracting. So this is 6. Is this 56? I think this is 56. What do y'all think? 56. And the 56 must add up to red and green, but both of them are the same. So I could just divide by 2. I could say the number of green apples, did I say mangoes? Apples is equal to 56 divided by 2. 2 into 5 is 2, remain now 28, boy. That's 28 green apples. Now the answer has a percentage here. So they want to know what percentage is green. So I'm going to put 28 out of the total, which is 70. Multiply by 100 over 1, and I'm going to hope for the best, boy. I'm going to hope for the best. So this is the percentage at green. Maybe I should have write this in green for the aesthetic sake. Percentage green. Yeah, that looks much better. So crossword is 0, crossword is 0. 7 could go into 28. 4 times 4 by 10 is a whole 40%. And some of you always saying 40% from the time I bring up the question. What happened? You could see in the future. Kavir. Well done. This is a new Kavir. Kanisha, well done. And Lisa. Nice, nice, nice. That's some Kavirs out there, boy. A pattern is used. Oh God, we love them pattern questions, boy. Them pattern questions is joy. A pattern is formed using the dots as shown below. How many dots will form figure 10? So what I want you all to do for these kind of patterns, come close to the screen. Come close to the screen. Make sure you turn up your volume, let your whole family hear everything. Here's how I want you to figure out these patterns thing, right? Check how much it's going up by. Once it's a steady number, you done figure out half the thing there. How much it's going up by? How much dots we have here? We have 3 dots. How much dots you have here? 1, 2, 3, 4, 5, 6 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 dots. Oh no. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 dots. Is that correct? How much dots is it increasing by all the time? So it's going up by 3. It's going up by 4. Then it's going up by 5. Yeah. Then you're going up by 6. Now, let me just verify that 6 now. Is that what you're doing? Is that what he's doing out here? 1, 2, 3, 4, 5, 6. Yes, and I now understand why you're doing that. Because okay, start off with 3, but it come like you add on this 3 in the back here. This is the original, and you add on the 3 here, and then you add on a 4, and then you add on a, you'll catch it, a 5, then you add on a 6. So this one is 21 then. Triangular numbers, you know the triangular now. You know the triangular numbers, boy. So if you want to go all the way up to 10, what we could do, we could say 21. You could come up with a formula, but we could also do this 21 plus how much we have to add on now? 7. So we need, this is the 6th one, this is the 7th one, 8, 9, 10. We need to figure out what this fella is here. That's the question, right? We need to figure out he. Well, all right, we need to add 7, then we need to add 8, then we need to add 9, then we need to add 10, then we need to add 11. Why isn't it chat if you understand all of that? So we need to keep adding on numbers to keep going up the ranks. Remember, this was the 5th figure. This is the 6th, 7th, 8th, 9, 10. All right. Well, maybe I could just sum up all of this as one. So 9 and 11 is 20, plus 10 is 30. 30 plus 7 and 8 is 15. 7 and 8 is 15. So it's 45. All of this adds up to 45. So the new number is going to be, or the 10th figure, or figure 10, that's how they write it. Figure 10 will have to be, we left it off on 21 dots, and we need to add on 7, 8, 9, 10, 11 dots, which is 45 dots. So if I add 45 dots to this, I will get 66 dots. Oh, some of you all getting these things out so fast, boy. Wait, but they're ready for essay tomorrow. So, all right, let me call the Ministry of Education and tell them to bring the exam tomorrow. Bring it tomorrow. Consider the fractions 3/4 and 5/8. Using words or diagrams to explain your answer. Using words or diagram to explain your answer. Are the two fractions equal to each other? Consider the fraction 3/4 and 5/8. Using words or diagram to explain. Oh, this is one of these kind of questions. All right, so maybe we could use a little diagram for them, boy. They're asking me to be the teacher now. Look at me. I am the teacher now. That's what you're supposed to say. I am the teacher now. Look at that. 8s. Are we cutting this solely up into 8s, boy? Right, it's kind of ain't looking too good, but we can live. So 3/4, maybe I should have used a pie chart. 3/4 is this. Right, 3/4. And 5/8 is 1, 2, 3, 4. You're missing it there by 5/8, but you ain't really making the cut. You ain't making the cut. So my explanation would be 3/4 is equal to 6/8. And this is 5/8. And 3/4, therefore 3/4 is not equal to 5/8. Oh, they say using words, but you need to follow the thing. 3/4 is not equal to 5/8 since it is equal to 6/8, which one, two, three, four, five. 1, 2, 3. Yeah. Since it is equal to 6/8, which is 1/8 more than 5/8. They can't ask for anything more than that. Well, I just write it out like this because I want it to be precise with my answer now, because they said using words or diagrams. So if I use the diagram and then I use this, next thing they're feeling a little funny about that. So it's not equal, right? Is it equal, class? No. Consider the fractions 3/4 and 5/8. 1, 2, 3, 4, 5. It's not equal, right? Yeah, everybody say it's not equal. Cool. Was it the nose going? A person goes to a hair salon and get their hair done for 320. They want to leave a tip of 15% for the stylist. How much is the stylist paid altogether? 15% tip. Well, let's get the tip. The tip would be 15% of the 320. 15% of 320, which will be cross. 5 could go into this 2 times, 5 could go into this 3 times, 2 could go into this 16 times. 3 by 16 is how much? Is 3 by 16 42? 48. Yes, what am I doing? 48. $48, why? A $48 tip. Always leave tips and thing. Always leave tips. Somebody saying 17 wrong. If it's blurry, you need to increase the setting on your side. Quite 17, my. So the shape below is not. Nah, 17 wrong. Nah, boy. You see that, boy? That person trolling. So 320. So the total tip, she rich. Total tip is 320 plus 48, which is 360. The total, this is not the total tip, this is the total paid. The total tip was 48. Pay altogether, total paid would be how much she's supposed to pay plus the tip, right? And Alec, you miss it by 8. Susanna has that. So if Susanna says so, it had to be so. Have to be so. Darian receive a salary of $2,400 per month. You receive a bonus of 1/5 of his salary each quarter. How much did he receive for the whole year? How many months in a year? Months in the year is equal to 12. So total salary Or is that? Are you insisting, and all them knows was you all insisting on me letting the ministry know that you're ready for exam tomorrow? 2400 and 2. So is this like 48 or something here? So I'll have 0048. Yeah. So when I add up this total salary, 00882. Is that the final answer? No, because he got a bonus. And the bonus is 1/5 of his salary. So let's work out what one bonus is. 1/5 of 2400 is what class? I can divide by 10 and multiply by 2 and get 48. Like if I want to divide by 5, I could say divide by 10. I think I taught that last week and multiply by 2, right? So I get 480. Or we can divide by 5. 5 could go into 24. 4 times remainder 4, and 5 could go into 48 times. So you get 480 as well. All right, but so we need to add. No. He get the bonus of 1/5 of the salary for each quarter. What each quarter mean? January, February, March, you get a bonus. April, May, June, you get a next bonus. You get a bonus for every quarter of the year. How many quarters? 4 quarters. So 4 bonus. 4 quarters. 4 quarters means that he'll get a bonus of 480 times 4. You have to multiply the bonus times 4 people. And this multiply by 4. What is this multiply by 4? 32 or something. 400, 48, 32, 33 there. 4 4s. 16 plus 90. This man making money, boy. So I see totals then. Where's the total he get for the end of the year? So the total, the final total of all the totals will be 28,800. That's how much you make on just his salary, plus the bonuses. Actually, that bonus in really too big compared to the salary. 0, 2, 9 and 87. Bring across the 1. Put a 0 here. Bring across another 1. 3, 0, 3. Yeah, boy. 30,720. And Isabella saying that is she answer too. No, yeah, Isabella saying that same thing I saying to, right? And Trizzle, you know. And Trizzle and them don't get them thing wrong. This is Trizzle using a mama account. Angelo. Yeah, most people saying my answer correct. Giselle and all saying this good too. So cool. Darian received 2,400 per month. He received 1/5 of his salary each quarter. Yeah, that's something good to me. Draw a quadrilateral with one pair of parallel sides. Parallel sides never meet, and they have to have 2 right angles. Geez and ages, how are we doing that? Sensing something. Sensing a way to make this happen. Watch this, sir. Feeling out a way to make this happen here, boy. So I will do is join this up like this. And hit this like that. Bam! Bang! And I know I get my thing there. I get my 2 parallel sides and I get my 2 right angles, and that is none other than obviously using ruler and thing, trapezium. Yeah, boy. And done saying it, that's the way to go. So if done say that, we have to believe it. At a parade, 25% of the attendees. Oh, good one of these questions, boy. So it's a whole parade. Boom. 25% of the attendees are wearing white. Maybe I should write that out to kind of like vibes it out. 25% of the attendees in white. 3/8 are wearing black. 3/8. Nice. 0.2 are wearing blue. So the bluers is 0.2. The remaining 14 attendees are wearing green. Oh my gosh, it's so much colors, boy. They could have go down to less colors, boy. Jeez and ages. How many attendees at the parade? Jeez and ages. Too much colors. So white is 25%. Is that maybe if I get all of them in terms of fraction or percentages, what is the way we think we should go by? Maybe we should go in terms of percentages. So let's keep all of them as a percentage and see if we can work out a little something. 25%. 3/8 is how much percent? Not 37.5. You know the 8th family. We talked about that last week. And 0.2 is 20%. Oh gosh. So 14 represents the remaining or the remainder percentage here. So let me work out how much all these percentages. Now I can do this with fractions or decimals too, you know. I can do this with fractions or decimals too. So far we have 25 plus 37.5 plus 20. If I patiently add this up, I'll get 5. 5 and 7 is 12. Across the 1, 3, and 3 is 6 plus 2 is 82.5% so far accounted for. So far, we have the white, the black, and the blue adding up to 82.5%, unless I'm mistaken, of the parades. That's what it's called, them parades, of the attendees at the parade. So the missing percent, the remainder, is it 17.5% to make up the 100? All you agree? 17.5% to make up the 100. Or I've seen some of y'all using a fraction method. So we could mute Avakin and yeah, we could, anybody who's spamming and doing wants that ridiculousness, all you gotta talk to, and you gotta write all your comments in about. You gotta write all your comments on a paper, right homely. Because we don't want the comments too distracting. The comments already very distracting, but the comments can be used to, encourage people and you see the answers popping and that kind of thing. But somebody using the comments to do wildness. Remainder is 17.5% earlier. So 17.5% is equal to 14. So how much is 1%? Finding for the unit will be 14 divided by 17.5. Finding for 100% would be 14 over 17.5 multiplied by 100 over 1. So I need to take my time and do this. How much marks them giving me to do this, boy? This seeming like it's too much work. All right, 140. 3 marks. All right, I can take it. 175. Now notice this little trick I do, hopefully on the path of righteousness here, because I move the point back one here and I move the point back there, so that I don't need to worry about any decimals with this fraction. And I'm still going to multiply by 100 over 1. And I'm hoping for my best to get my total number of. Everybody keeps saying 80. Maybe it's 80. Maybe it's 80 earlier. Do we have how much times I'm saying is 80? 25 could go into this. And 25 could go into 100 4 times. 25 could go into 200 8 times. 25 into 175 is 7 times. So 25 could go into this 4 times now. And then 7 could go into this 14 2 times. So 7 could go into 140 20 times. So 20 times 4 is 80 people at the parade. And somehow these people figure that out so fast. So fast they figure that out. 80 attendees. Now, some of these students here, let me tell you all a secret. Some of these students here are in my Saturday class. Every Saturday, I have a class, or they are in another class in the student hub, which is the online school that I have. So every Saturday, I have a class from 9 to 10:30. Sometimes we go a little later. Depends on whether we're playing rock, paper, scissors or something at the end. So, all right, it goes from 9 a.m. to 10:30. And in this class, we do topical revision. That's where we are at now. We're just doing our sitting style of questions. Like this week, we did fractions. And I told my class something. I told my class two things. I want to come to these two things that I tell my class, and I want to tell her too. But and a perk they have been in the class is today when this session is over, they get sent the. In fact, I think they got sent it yesterday. They get sent the exam that come in next week, that I'm going to do next week on the Sunday revision session, and they have to do it and send it up, and we correct it, and we give them back the results. We don't give them back the solutions until after today, but so that's why some of them probably train or they answer fast. People like, let me see if I can find one, like maybe this guy here, this guy, and this girl. All right, so the two things I told them is, or the two things are, one, can I remember this, boy? It's important to remember this, people. Just now, it coming to me. It coming. It coming. Two. It's still coming. It's still coming. It's taking a long while to download. Oh, I remember now. You see how I have the cold now, and like I'm sweating, and my throat is hurting, and I'm feeling a little sick and thing. Yeah. But I'm still here teaching the class. I think there is a trait. You know what a trait is? A character trait of super successful students. How you spell success? Is it 2 C's and 2 S's? Super success. I don't take English lessons from take math lessons, but I think I correctly successful. There's a trait of the super successful person, right? And we give this one a keep and put S on it. The super successful student, not necessarily that they're more bright or anything, you know. They have the ability, listen, to do things that they need to do even when they, what am I going to write here? Even when they don't feel like it. So if you want to join the super success with the keep and fly and them kind of thing, maybe not fly, but fly, your grades will be flying high. If you want to be high up there, you need to be able to, you're listening to what I'm saying, you need to be able to do things that they need to do even when they don't feel like it. You need to be able to do things that you need to do even when you don't feel like it. Some of you all will only do things when your parent nag you and quarrel at you for like 1,000 times to go and study, you go and write, and you didn't do that question, go do it. No. When you finally realize that you want to fly and you could do it for yourself, you're on the road. You're on the road to super successfulness day, boy. You're on the road to super successfulness day. That is the road day, and you're on the journey. And once you're on the road, you're winning. From the time you decide to get this mindset and you're on the road, you're winning. You're winning. So from the time you decide that I am going to do things that I need to do even when I don't feel like doing it, even if I feel a little sick or tired, yeah, you get through. You're on the road to winning. It's important to remember that every single excuse that you come up with may be very legitimate. I could have said, I feeling sick, I'm not going to teach nothing and stay home and watch Netflix. Watch Netflix. But I decided that I do not want to break the trend. I want to keep every single class straight up the exam every single Sunday. So I hear. And because of that, because of behavior like that, I have 107,000 subscribers on YouTube, but you have to be very consistent to have. So if you want to be super successful in your exams, you shouldn't only study when your parents and teacher tell you to study. You shouldn't only write and do questions and go over the tough things when your teacher tell you to do, right? The good thing about this is that when I cough like this, I ain't getting no cool. You know, the beauty of online classes. All right, the second one taking a long while to download, people. So maybe it will download at the ending of class. It's still coming. It's still coming to me. Something else I told my class that was important. Let me go on with number 31. Consider the diagram below. How many more cubes are required to completely fill the cuboid? Is that too small? Let's zoom in a little bit. That has a small ident. Ooh, how much more we need, boy? How much more we need to make this happen? This is a piece of bacchanal here. Let me see how much we need in total. In total, I feel we need how much cubes to make a face. I'm going to tell you about the face pattern. We have how many going this way? I think we have 1, 2, this is the same 2, 3, 4, 5, 5 going this way. Watch this. 1, 2, 3, 4, 5. This one going from end to end. 5, right? Are you agree with me? So we have 5 going this way. How much you have going up top? 1, 2, 3. 3 going this way. I need something else. I need to figure out how much going this way now. 1, 2, 3, 4, 5, 6, 7, 8, 9. Why isn't it that if you agree with me for these? What we call these things dimensions. You all agree that these would be like the dimensions in terms of cubes? I think that is a good thing. So hopefully you're correct. 5 by 3 is 15 cubes on a face. And how many faces we'll have dragged this way? 15 by 9. So in total, we need 5 by 3 by 9, or 15 by 9. 15 by 9 is how much, class? 15 by 9, 9 5s are 45. 5, 4, 9 1s, 135. 135 cubes. That's not the answer. That's how much we need in all. But we're very close to the answer now. Very close, because they want to know how much more now. They already put in some for we. So I'm going to take my time and count them. But when I count them, I'll use my pencil, my pen, my little pointer thing here. This always look earlier. This always look. My little pointer thing. I'm going to use that, and I'm going to draw up a number of my cubes here. 1, 2. Don't think you're hiding there, bro. Like 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21. I get 21. How much did I get? I get 21. So how much more we need? So we need 135 minus 21. Because 21 done there already now. 1 from that is 4. 2 from that is 1. 114 cubes. 114 cubes. A pen write properly now, but you're trying to make me lost marks. So Navin and Maurice. I know some of y'all, the names are calling here might be a parent name are calling. 2 triangles are shown below. Shape P, shape Q. Right? 2 difference in the properties of shape P and shape Q. Well, this one is an isosceles. This one is an equilateral. So in shape P, all angles equal and all sides equal. In shape Q, and all angles are equal to 60 degrees, by the way. Only 2, I just not write 2, but it didn't come out. Only 2 base angles equal. The third one isn't equal. So these 2 are equal, but this one is different. And only 2 sides equal. And we collect we marks, and we do so. and they roll out. All right. 33 using. Now, boy, every week they're making this thing more and more complex. Every week, boy. Every week, because they realize this is the cooler spot now, boy. So I go 3 this way, so I go 3 this way. I'll leave a double check and make sure my points them lining up. And that week they nearly catch me with this, you know. And dot. You understand that? This point, I just put it up there. You understand? This is these 2 points here. I'm gonna put them up here one time. 1, 2, as the same space apart. And then this one will be here because there's a point here. So what I'm doing is using the vertices of the shape to come up with my ideas, boy. What a shape this is. What a shape. Maybe the man in SEA is go through the whole year thinking about the nice little shape to give Alena. What is the shape? What is the shape? And by Christmas, sometime in New Year's, he's getting the idea. This is the shape. This is the shape for this year. I wonder what the shape for this year gonna be, boy. I wonder if the line of symmetry gonna be diagonal. And this is the part of the exam where you're taking a little cooler, but still remain vigilant. You don't want to lose any marks. Silly here. Actually, didn't need to put that point there because this one comes straight down. And you see how I drawing this thing freehand? For goodness sake, don't do that in the exam. Use a ruler. So let me hit them the little double checks. Zoop. That looking symmetrical, tell you. Maybe you had to turn the paper sideways to just, yeah, that looking good, man. That looking good. Somebody reminded me not to forget 18. Now, remind me when I reach the end now, not to forget 18. Rhea has the solid shown below Rhea has the solid shown below made up of 6 squares. For a while, I didn't understand what they're saying here. It just means you have a cube. Each edge measures 6 centimeters. Write down the name of the solid cube. Marks, boy. Look at that. I wish I could get marks for writing cube in an exam, boy. Oh, geez, I delete the whole thing. So I just wanted to try and spell it a little better. Cube. What is the total length of all the edges? That is space. So they didn't ask for the volume. They didn't ask for anything like surface area or any weird stuff. They asked for the length of all the edges. How many edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you should know this often. There are 12 edges on a cube. So if there are 12 edges, the total length of all them edges, boy, it can be 12 times the 6. That's a 12 right there. It's just that the 2 come out kind of funny. 12 times the 6, which is 72. We know that from our tables. 72 centimeters. We have 14 pins on each face. How many pins? Oh my gosh. So 14 pins on each face. So we're talking about a face now. How many faces does a cube have? A cube has 1, 2, 3, 4, 5, 6 faces. Why are my letters skipping? I might need to reload the blackboard just now. There. So we have 6 faces, and on each of these faces, you all understand, each of these faces, she's sticking pins. She stick 14 of them. I'm not going to draw 14 pins there. That seems like a waste of time. So 14 pins, 6 of them, 6 faces. So how many pins in all? 14 times 6. 6 fours are 24 and 6 by 1. So it's 84. 84 pins. And Celine is saying that sounds like a good answer. So if Celine says so, it must be so. And Nell too is so. 84 pins. Coming down to the end in here, a merchant bought 40 sheets at $15 each and sold them for 4 for 75. Calculate the amount of profit they make. 40 sheets, 4 for 75. 4 for $75, boy. Let me check out the selling of this. It's 40 sheets, and every 4 is 75. So how much you think 40 gonna be then? That real quick to see, right? You just add a 0 there, so I might as well just add a 0 there. The profit the merchant made, and that's on all these sheets, right? Well, how much did you pay for all these sheets? 40 by 15. So this is the selling price, but the cost price of all these sheets will be 40 by 15. 40 by 15 is how much? 40 by 15 is 600. 4 by 15 is 600. $600. So the profit, is it that we need to work out the profit percent, just the profit? So the profit is going to be, y'all stop saying sir, just type your question one time. The profit is going to be 750 minus 600, which is 150. 150. Yeah, don't forget number 18. No, see now, don't forget number 18. I feel like I go and find number 18 now because they keep telling me don't forget number 18, don't forget number 18, don't forget number 18. But I go and find number 18. Number 18, you thought you could have escaped. You thought you could have escaped, but you thought wrong. I find it earlier. I find number 18. I'll put down number 18 here before some people lose their mind. How many quarter turns must Hannah make to get to the mall? Where are we making quarter turns here? Hannah is going this way and she made a 270. Well, you could call this a quarter turn too. Quarter turn. So well, you're looking for the right angles then. 1, 2, 3, 4. 4 right angles. 4 quarter turns. Zoop. Zoop. Run. Quarter turn. We've seen it. Why are you all saying 3? I am saying 4. 4 quarter turns. Now, technically, altogether, she was facing south and now she's facing north. So technically, it's only 2 quarter turns overall, like altogether. But she do all kind of thing here, but she went this way and then she went this way and then she turned back and then she turned back, and our course she did have to do it 4 times. Okay, number 18 is done earlier. Number 36, we're nearing the end. We are nearing the end. This was the fastest paper for us. The chart below shows the number of products manufactured by a factory in 4 months. How many? That is it. How many products were manufactured during the 4 months? So I'm snapping this for future reference. I want to make a question similar to this in one of the exams coming up. How many products were manufactured during the 4 months? Is this just an addition? I feel like we do this for the paper already, boy. 2,000. I have my pen fighting me down here, so I'll allow me. 2,000, and this is in between. That must be that what they're testing. In between 2,500 and 2,000, the middle of that will be, tell me if I'm wrong now, 2,250. I know that. I know these things. And this is 500, and this is 1,500. So yeah, in between 2,000 and 2,500, the middle of that is 2,250. You can check it out. Add it up and divide by 2. So if I add up everything here, I am getting 0, 0. Oh, no, that's a 5, boy. That's 5. And again, a 2, a 1 will transfer over here. 6, 2. 6,250. 6,250 products. Just a few more to go. Nathan is selling 4 different types of fruits at a market. This is a question from Question Land. I'll look at this question here. The average price of 2. Now, SEA did some questions similar to this, and they also did a comparison question, sometimes with some eraser and pencils and things. Have the similar idea. Watch this question. The average price of 2 of the cheapest fruits. Okay. So the 2 cheapest fruits might be a square and a triangle. Average price is $3. If the average is $3, how much is the cost for the total of these fruits? To get the total, you multiply 3 by 2, you get $6. That's you could always find the sum. You can always find the total if you know the average and how much you have. We don't know how much each one of them cost, because maybe it's 4 and 2, or maybe it's 3 and 3, or maybe it's 5 and 1. We don't know, but we can figure that out. The average cost of the 3 cheapest fruits. Let's bring a circle. So the 3 cheapest, now remember it's going down in price, right? So the 3 cheapest fruits will be these 2 plus this one, and the average price is $7. So the total cost of all of these fruits will be how much? 7 3s are 21. Now I am seeing something here to help me figure out this question one time there. That's the trick. Because if I throw in a circle and all of a sudden the total price gone from 6 to 21, and I can find out how much the circle is, I can find out how much the 3rd cheapest fruit costs. I can find out how much the 3rd cheapest fruit costs. The average price of all 4 fruits, let me throw in our next fruit then. Average price of all 4 fruits, the circle and the parallelogram, I'm doing it in a kind of graphical representation, is 8. So 8 by 4 is $32 for all these fruits. So I could figure out the parallelogram. So the most expensive is 32 minus the 21, which is the cost of this is average price of all the 4 fruits is $8. So this question may actually have an error in it, because I'll explain the error just now, but let's keep going. So one of the fruit is $11. This is 11. The circle, the circle. So I have the fruits as shapes. And I got that this fruit is 11. This fruit would be 21 minus 6, which is 15. And what else? So we know this is 15. We know this is 11. And we know these 2 add to give us 6. So there is a bit of vagueness in this question. Sorry, I have it in the wrong order. This is 11. So those who did this question, I want to apologize. And this one is 15. There's a bit of problem in this question, because average price of the 3 cheapest fruits is 7. 7 3s are 21. It means the new fruit that we add in cost 21 minus 6, $15. But when we add in the other fruit, which is supposed to be the most expensive fruit, it was only $11. So there's a problem here. And there's also one other thing that I need to add into this question so that we can be able to differentiate the last 2 fruits. So there's a problem in this question. This question needs to sort out. Problems in this question. Big problems. So a couple of people watching this stream and they're watching it delayed. So that's why they keep saying that I didn't do number 18. They probably now seeing number 18 popping up in their stream. They're behind them watching it in the past. All right, so the fruits prices could be 15, 11. In this current thing, 11 and maybe like 4 and 2. That will work with everything. But there is a problem in the question. And I'm very sad that there's a problem in this question, because it's a really nice question. And the way to do the question is like this. All right. For those of you who are wondering about number 18, it's over here. It's 4 quarter turns. Using metal rods, the following pattern was made. Another pattern question. So other than 37, this was a really beautiful paper here, because we have a next pattern question. And 10 metal rods were used to construct 1 square and 3 triangles. So you have 10 rods, 1, 2, 3, 4, 5, 6, 7, 8, No, that was already counting. 5, 6, 7, 8, 9, 10. So we have 10 rods here. How much we'll be using here? We have the 10 already set here. So we'll be using 10 plus 3 plus another 3. We'll be using 16 rods here. You can count up all if you want, but I'm seeing that that'll be 16. And I count up all here and it'll be 22. Y'all want to count it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 22 rods. So it keeps going up, and this is another pattern question where you need to watch. If it's going up by a consistent value, you use that as a multiplier. I'll show you what I mean. It keeps going up by 6. It keeps going up by 6. So how many metal rods will be used for pattern 6? We need to figure out. You always multiply by how much it's going up by if it's consistent. So if it's always going up by 6, to get pattern 1, we'll multiply by the multiplier, 6 by the first pattern, and we'll get 6, but notice it's 10. So we always, after we multiply by 6, we needed to add on 4. So it's 10. I hope you're all paying attention. This kind of deep. With this pattern, we multiply by 2. So 6 by 2 is, how much is 6 by 2? The second pattern. 6 by 2 is 12. And then all of the patterns, we keep adding on 4. So after you multiply by 6, you need to add on 4. See that? So that's how we get 16. Check it out for the third pattern. I'm going to try and write a little slower because this pen is slowing me down, man. So 6 by the third pattern, 6 threes are 18 plus 4 is 22. So you'll understand how to work out the pattern now. The number that is going up by consistently, you'll multiply by the figure that we have. So if they want you to figure out the 6 square, 6 square means the 6th figure. To quickly figure it out, we can say it's going to be 6 times the number 6 plus 4. 6 times 6 is 36 plus 4 is 40. There's another way to do it, and this other way is a little longer, where you need to keep adding on 6. Say add on 6, add on 6, add on 6 and add on 6. And add on 6. Because we need to reach 4, 5, 6th figure, yeah. So 6 plus 6 plus 6 is 18 plus 22 is 40. That's another way you could do it. So it's always 6 times the figure plus 4. Oh no. So the total metal rods used in a figure was 70. There's some figure way down the road. Calculate the number of triangles in this pattern. Oh my gosh. Well, the number of triangles going up. Let's just stop and think about this, boy. The number of triangles is always 1, 2, 2 more. This is how many triangles do we have here? We have 3 triangles here. We have 5 triangles here. 1, 2, 3, 4, 5, 6, 7 triangles here. The number of triangles is what? How do we figure out the pattern in the number of triangles? It's going up by 2. So the number of triangles is 2 times the figure plus 1. Is that working for the number of triangles? 2 times pattern 1. 2 times 1 plus 1 is 3. Let's try pattern 3. 2 times 3 plus 1 is 7. So that works. The number of triangles is always 2 times the number of figure, or 2 times the number of squares plus 1. But if we have 70 rods, how will we know what figure it is? Simple. You need to subtract the 4 and then divide by 6. You need to go backwards. So we're going to say 70 minus the 4. Oh, I hope you all following. Some of you all will need to swing back and do over and watch over this over and over. But I'm seeing all the explanation very clearly. So the 4, we always have to keep adding on 4 after we multiply by 6 to find the total number of rods from before. If I want to go backwards, if they give me the number of rods, I will need to say 70 minus 4 is none other than 66. And then I'll need to divide this by 6. And 66 divided by 6. This means we are on the 11th figure. So I just figured out the figure. It's the 11th figure, or 11 squares. But how do I figure out the triangles now? Because that's what they want to know. How many triangles in the pattern? It's going to be, I need to always multiply by 2 and add 1. So the number of triangles good thing we're on the close to the last question, because my board starting to freeze up. The number of triangles is going to be 2 by 11 plus 1 is 23 triangles. How many of you all got that? 23 triangles. So I am aware that this is a tough question, and that not most of the average student, you all need to come back and watch it. So I am teaching you something really important about patterns in this question. So if it's always going up by a consistent number, that's the number you'll multiply by, and you'll need to add something in CXC. I call this the balancer. You always need to add or subtract a number after you multiply. Maybe the number is 0. Maybe you don't need to add or subtract anything. So in this one, we multiply by 6 and we add 4 to get the total number of rods all the time. That's how we get 10, 16, 22. So if we wanted to go backwards, we needed to do the opposite. We needed to subtract the 4, then divide by the 6. Really challenging question here. Very challenging. 39 is not so bad. 39 is not so bad. What fraction of a turn does blade M make if it turns in an anti-clockwise direction to the position of blade N? Anti-clockwise means against the flow of the clock. So what's that angle there, folks? Well, they don't want the angle, they want the fraction of the turn. What fraction of a turn is that? That's a 3/4 turn. Well done. So that's not so bad. We're back to easy stuff. 3/4 turn this way. How many quarter turns does blade L make if it turns in a clockwise direction to the position of blade N? More easy thing. How many quarter turns? Just make sure you answer the question correctly to what they want. So if you was in the position of blade N and we turn L as in love, and we turn to blade N as in no, we make 1, 2 quarter turns. 2 quarter turns. And easy, we're racking up them maths one by one. Through how many degrees does blade O turn in a clockwise direction to the position of blade N? So they ask about fraction, then they ask about the number of quarter turns, now they're asking about degrees. You understand? Now this question mixing it up like Baji. Through how many degrees does blade O turn in a clockwise direction to the position of blade N? O to N clockwise. O to N clockwise is the same 3/4 turn, but they want it in terms of degrees. Clockwise, so it needs to go this way. O to N is 3/4, or in terms of degrees, that's 270 degrees, ladies and gentlemen. 270 degrees. If blade L, if blade L travels 200 to make a whole turn, how many quarter turns will it make in 650? All right. Well, we need keep in mind that a whole turn is 4 quarter turns, right? We need to figure out how much whole turns in this thing, boy. How much times 200 could go into 650? So 650, or maybe an even better thing to do is say if 200 is a whole turn and I have 4 quarter turns there, I can say 50. I find this is the better way to do it. 50 centimeters is a quarter turn. Why isn't it chat if you agree with me there? Because I want to divide and I will just find my answer one time. If one whole turn taking 200 centimeters, quarter turn will take 50 centimeters, a quarter of 200. I divide it. And then I could say a number of quarter turns. I want to write number of quarter turns. A number of quarter turns would be equal to 650 divided by 50. How much times that can happen? 13 quarter turns. 13 quarter turns. Yes, sir. Last question. Using the square grid below, join 4 dots to form a quadrilateral with no right angles. No right angles, but you still have to pair parallel sides. You want a parallelogram to do this, boy. But you have to be real careful out here. If you choose this one, you know you're wrong, because this line and this line are parallel. 2 pair of parallel sides. I am seeing like I could choose this guy and this guy will do that. Them gonna do it for me. How about you? You'll see that could work. That's unique to a scene. Only set a scene. And that's a parallelogram. So I'll have 2 pair of parallel sides. But notice how none of them are right angles. Name the type of quadrilateral drawn. Para, 1 R, 2 L's, and then an XL. Parallelogram. Parallelogram. Logram. You know to spell parallelogram. And we done. This paper had 1 or 2 tough questions in it. It was a beautiful paper. But this I was sad about. I was really sad about this question. This question had a big problem. I'll fix this question. What y'all think? You know what time it is? It's shout out time. How the revision going, boy? How the revision going, ladies and gentlemen? For those of you all who thinking about number 18, it was done. The answer is 4 quarter turns. Oh gosh, I came the number 18 day. There it is. We did it. Maybe a step away when we was doing it. I hope the revision going good with everybody. What was the second thing I tell my class? Maybe next week. Next week I get tell you a story. Next week it's gonna be story time. The early crew next week I will give away something for the early crew. Maybe I'll give you all discounts or something like that. So something you can take advantage of for the early crew. Today was a class I kind of just powered my way through. I wasn't 100%. So I'm sorry if I made a couple mistakes. So the energy wasn't as it usually is. But we done. And now I can do the shout outs. Kelvin, what is he seeing? Peaches, Nell, Jada, Danielle, Amelia, Zoe. I see Zoe write her name. Is it Koran? Kira, Jada. Yeah, tall boy from school. I take a picture with this boy. From Tabakit. Eli. Zach. Lillian. Hi. I see you doing all your questions and answering them really fast. Big up Aruka government. Big up your school. Lillian, Nicole. Yep, that's how you spell trapezium. Gameplays, what's up? Shekinah, there we go. Just maybe a couple more. Hi, Donna. Malachi and Rebecca. Big up yourself. And Yeshu and Precious. King. Josiah, what's up, bro? What's up, buddy? I hope you're studying and you're doing your work. Celine, Cadell. A lot of people names start with gamer this, gamer that. I hope you're not living up to that name right now after exams. Cadell, Annalie, Jordan, Jadan. Done. What's up, Dan? Dan, you answered some good questions. Eh? All right, Relic. And Faith, what's up? Hello. All right, so we're going to put an end to the shout outs there. Love and blessings. We will see you all next week at 1 p.m. on a Sunday as usual. We just have like about 6 more of these to go. 7 more. I am also thinking that I will do a session where I'll just do fractions. Like the whole Sunday session will just be doing fraction style questions. and one session where we'll just do unequal sharing style questions, just unequal sharing style questions, which is like tough fractions. All right, later, people.